Hello class, today we are going to talk about divergent boundaries and seafloor spreading. Our learning objective today is that students will be able to describe the movement along a divergent plate boundary that results in the formation of new oceanic lithosphere. We're going to start off our lesson today with a video, then we're going to continue our lesson through this PowerPoint, and we will then do a partner diagram activity as well as partner presentations. We will end our lesson today with a short quiz assessment. We're going to start with this video about seafloor spreading.
During World War II, scientists at sea were using sophisticated echo technology to track submarines when they turned up surprising information about the ocean floor. There they found a stretch of underwater ridges made of continually erupting volcanoes.
The mid-ocean ridge is formed when molten rock rises from inside the earth and then pushes the crust apart.
A vast spreading seafloor strong enough to move the continents. Not only is new crust formed at mid-ocean ridges, but it dips back down again into the interior of the Earth.
You put this all together, and what you get is plate tectonics. The idea that the Earth's crust can be broken up into large pieces or plates that consist of both continents and also pieces of oceanic crust moving together over the face of the Earth.
When two plates collide, sometimes one is pushed downward and melts into magma. Eventually, this red-hot material rises to the surface and explodes, creating a volcano. So new crust is born at mid-ocean ridges and destroyed at deep ocean trenches, like a never-ending conveyor belt. And two plates simply nudging each other can cause catastrophic results, like when the San Andreas Fault slipped in 1906. How fast do the plates move? If you live in the US, you're probably standing on the North American plate. In the course of 1 year, the ground under your feet will move about 2 inches. And over long periods of time, that's enough to reshape the Earth, build mountains, trigger earthquakes, and create volcanoes.
All right. Now, we will be talking about divergent plate boundaries. Divergent plate boundaries are located along the crest of oceanic ridges. And as we can see from our diagram, oceanic ridges are this space right between these two arrows. We call divergent plates constructive plate margins because they are what results in new oceanic crust. We also call them spreading centers because of their spreading quality of moving outward, as you can see. So this magma at the bottom is going to be what pushes in between the spreading of the plate boundaries, and that's why they are constructive plate margins, because while magma and molten rock pushes towards, it's going to cool and create new oceanic crust in the center of this oceanic ridge. Now we will go more in detail about oceanic ridges. So, some characteristics that oceanic ridges have is that they are of elevated areas. As you can see from this picture, you can see how it looks like this, the surface is kind of pushed up where the ridge is, and that is because this magma underneath is pushing up, so it's going to push all of this up and cause this elevated area. It's also categorized by its high heat, and this again is because of the magma underneath. Magma is extremely hot, so it's going to make this oceanic ridge hot as well. It's also volcanic, as again, because of the magma underneath and it's spilling out from the top. That is a volcano characteristic. Next, we're going to talk about rift valleys. So, as we can see from this image on the bottom, this is the Rift Valley in the center of this continental lithosphere, and this is also continental lithosphere. So what happens is the divergent plates pushes these continental lithospheres out, which causes the sinking in the middle, which is what the Rift Valley is. So Rift Valley are in some ridges, and they are a canyon-like structure that are evidence that there are tensional forces that are pulling the oceanic crust apart. We can see an example of a rift valley from the Iceland rift, which is up here. So right here would be the continental lithosphere and the edge of it right here. All right here is going to be that rift valley that we are talking about. Next, we're going to talk about seafloor spreading. As we mentioned before, seafloor spreading is caused by divergent plates that are pushing the plates outward, causing this ridge in the middle. So, this magma and molten rock is going to push towards the front. It's going to form crust, which is what this is right here. It's going to form new oceanic crust. And as more and more forms, it's going to create like this motion like this, where older crust is going to be pushed this way, and new crust is going to be formed in this center right here. The average spreading of seafloor spreading is about 5 centimeters a year. Remember that number, 5 centimeters a year. That is about the same amount of fingernail length a human grows within a year. Next, we're going to talk about continental rifting. So, the start of continental rifting is again by divergent plates pushing outward and magma pushing upward. It's going to cause this type of rounded structure. Next, you're going to have this continental rift in the middle because the plates are pushing this way, which leaves this gap in the center. This is very similar to the Rift Valley we were just speaking about in the last slide. Next, you're going to see a linear sea, and this is due to the new crust being formed and water being formed into here. So after this process is repeating and more crust is being formed, as you can see, the oceanic crust is only about that big, and then down here it is this big. And that is because more magma is pushing in the middle of this rift valley. So this process is just continuing and causing more seafloor spreading, causing the range of the sea to expand. Okay. Also note the continental lithosphere right here compared to the oceanic lithosphere right here. And also that we have a asthenosphere down here that is also mixed in with the magma, and it's going to be cooling to create more continental lithosphere. Next, we're going to take a look at this video that I think does a good job of briefly summarizing everything we just went over. We're only going to watch about the first minute of the video because after that, the topics
There once was a colt.
Something that we're not going
Welcome
to
to
go over
Moo Math and
until
Science
our
and
next
Divergent
lesson.
Plate Boundaries. Divergent plate boundaries occur where huge tectonic plates move away from one another. This occurs above rising convection currents. The rising magma pushes up on the bottom of the lithosphere and flows laterally beneath it. This lateral flow causes the plates to move in the direction of the flow. At the plate boundary, the two plates move in opposite directions. Divergent boundaries are constructive boundaries because new crust is formed. As the plates move apart, molten magma fills in the gap and creates new crust. If you look at the map of the major tectonic plates, you can see several divergent plate boundaries. There are two major types of divergent boundaries: continental and continental lithosphere, and oceanic.
All right, so we're going to pause right there because those two terms are something that we will not be going over until our next lesson. All right, so next we are going to do a diagram activity with our partner. So you and your partner are going to fill in the blanks on the worksheet that you have at your desk. Fill in all these little blanks with the words you believe fit in there from the diagram that we just went over 2 slides ago. So some of them are going to be repeated, such as upwelling. That's going to be repeated 4 times, so just watch out for that. All right, now after you finish going over this diagram with your partner, we're going to review the answers. You can go ahead and correct your mistakes. All right, next we are going to be doing partner presentations. So you and your partner, same partner from your diagram activity, are going to choose a real-life example of either seafloor spreading or continental rifting. Some examples that you can choose from is the Atlantic, the Rift Valley in Iceland, the East African Rift, and the Red Sea. You can also choose other examples if you've seen another one in our textbook or you're just aware of another one. With approval, you can choose those topics as well. You're going to present to the classroom how these mechanisms are working. So how the magma is pushing, where the divergent plate is, identify the rift, identify the valley, everything like that. Tell us what stage of continental rift it's in, and explain seafloor spreading to us if that's the example you're choosing. All right, after that, we are going to do our assessment quiz. You are going to sketch or describe how 2 plates move in relation to each other along divergent plate boundaries. Next, you're going to say what the average rate of seafloor spreading is in modern oceans. In other words, how many centimeters per year does seafloor spreading occur? Next, you're going to list at least 2 features that characterize the oceanic ridge system. And then next, you're going to briefly describe the 4 stages of continental rifting and name a location where continental rifting is occurring today. And that can be at any stage of continental rifting 1 through 4. After you have completed this quiz, go ahead and turn it in, and that concludes our lesson today.